Physics 101, spring force and centripetal acceleration homework number 10. Number 10 out of 10, the airplane problem. We have an airplane, it's going around in a big circle, and you can see that it's banked at an angle of theta. We are given the mass of the plane, so it's right there. We are given the radius of the circle, and we're given the period, which is how long it takes to make a complete circle. Now, unfortunately, we're given the radius in miles, so we're going to need to make a conversion. You're going to have to convert that into meters, and because ultimately we're going to want a lift force in newtons, well, kilonewtons, so be careful of that. But we'll have to go to newtons first before we can go to kilonewtons. So we got to put it in meters, and we got to put hours into seconds. So make sure you do those conversions right off the bat. As you write down your given information, put it in the units you want. So we are given, we're asked to find the lift force and to find the angle theta. That's our angle theta right here. The lift force is going to be going straight up from the point of view of the airplane. The only other force acting on the airplane is gravity, which is going to pull straight down, Fg, which equals m times g. Now that lift force, it's at an angle. So it's got a component in the x direction, and it's got a component in the y direction. It's not accelerating up and down. There's no up and down acceleration, which means that the force up equals the force down. So if this is F lift, or just L if you want to use the same notation as the problem, then this is going to be F L in the y, or L in the y. The y component, I like FLY because it spells fly, but and it's a plane, so that works for me. But it's just the y component of the lift force. The y component of the lift force is going to equal the weight, and we can figure out the weight because we know the mass. So FL in the y direction equals m times g, and we know both of those things. So we can figure out the y component of our lift. Now we need to figure out the x component, FL in the x direction. How do we figure that out? Well, that's the force that's causing the centripetal motion. That is the centripetal force. So FL in the x is going to equal FC. And FC equals mv squared over r. Neat, except we don't know v. We know m and we know r once you've converted it into meters, and m's in kilograms is what we want, but we don't have v. But we do have the time it takes to complete one full circle. That's what the capital T means. It's the period. That's the time it takes to go all the way around. So to start here, go all the way around the circle and come back to where it was. So the time to complete one rotation. So if I want to know how fast it's going, I take how far it went and divide by how long it took. That's the average velocity. That's what we want because it's going at a constant speed. It is changing. The direction is changing, but the magnitude of it isn't changing. So that's going to be our v value. How far it went is going to be 2 times pi times r. And how long it took, capital T. That's how I find my v. So I'm going to use that v to figure out the centripetal force, which is equal to the x component of the lift. So now I know the lift in the y direction. I know the lift. Oops. Keep doing that. I know the lift in the x direction. I have the two components. I can figure out the vector. So if I know how much of it is in the x and I know how much of it is in the y, I can figure out how much of it there is using a little bit of trigonometry. I can also figure out the angle. But if I draw my triangle like this, the angle that I figure out is this one, and that would be this angle here. That's not the same as theta. We got to figure out which of those angles is the equivalent angle to theta. Now, I'm going to leave that to you. You've got to figure out how to get that theta angle. You have to do a little bit of geometry. It helps to look at the picture. But I'm going to leave it at that. Oh, I'm not going to leave it at that. So bonus material. Don't forget, it's in kilonewtons. That's 1,000 newtons. Once you find your lift force using the Pythagorean theorem, you're going to get it in newtons. To go to kilonewtons, you're going to have to convert. 1 kilonewton is 1,000 newtons. Now, I'll leave it at that.